evaluate limit as x goes to infinity of 1 plus 1 over x to the x power. If we simply evaluate x at infinity, we get 1 plus 0, which is 1, to the infinite power, and so this is definitely indeterminate. The trick here is to take our limit and set it equal to L, and then apply the natural log to both sides. Doing so would allow us to interchange limit as x goes to infinity with the log, so we get limit x goes to infinity, natural log, 1 plus 1 over x to the x power, equal to the natural log of L. So hopefully we can evaluate this using L'Hopital's rule and properties of logs, and this will not be our answer, but it will be the log of our answer. But in that way we'll be able to get the answer L that we're looking for. So the most natural thing to do here is to take the x and put it as a coefficient of the log. So we get limit as x goes to infinity, x ln 1 plus 1 over x. And if we just try to evaluate this, we're going to get infinity multiplied by natural log of 1 plus 0, and the natural log of 1 is 0, so we get the indeterminate form infinity times 0. So we saw how to do this earlier. Take the limit as x goes to infinity, ln 1 plus 1 over x, and make it into a quotient. So instead of having x as a coefficient, we'll have 1 over x as the denominator. And now, if we let x go to infinity, we have the indeterminate form 0 over 0, in which case we can apply L'Hopital's rule. Doing so, we get limit as x goes to infinity, derivative of the natural log of 1 plus 1 over x. Well, that's going to give us 1 over 1 plus 1 over x. And then we'll have to multiply by the derivative of 1 over x, according to the chain rule, which is negative 1 over x squared. All of this will be divided by the derivative of 1 over x, which again is negative 1 over x squared. Fortunately for us, before this gets too out of control, the negative 1 over x squareds cancel. Now, we can evaluate this and let x go to infinity. The 1 over x term is going to go to 0, and so our answer is going to be 1 over 1 plus 0, which is equal to 1. So, ln of L is equal to 1. Remember, this limit is equal to ln L, which is equal to 1. Our original problem was to find L itself, and to do that, we just use the exponential, and L is equal to e to the 1, which is just e.